Okay, so we're going to start off today talking about proportions. We've been talking about ratios, and we want to move on to talking about what exactly a proportion is. So we want to cover our learning targets first. First of all, we're going to find out what a proportion is. We need to be able to identify a proportion. It doesn't do much good to talk about something unless you know what it is. Second, we want to be able to complete proportions with missing values. So when we get a proportion and it's missing something, we want to know how to fill it in. And then lastly, we're going to take proportions and we're going to use those to solve real-world problems. So we're going to solve real-world problems using proportions. So let's begin. We'll start by looking at the definition of a proportion. A proportion is an equation that shows two equivalent ratios. So two equivalent ratios. And if you remember when we talked about before, a ratio is simply a relationship between two numbers. Let's say we had 3 dogs, and for every 3 dogs we had 6 cats. That is a ratio, 3 dogs to 6 cats. Now a proportion is an equation that shows two equivalent ratios. An equation, of course, uses an equal sign, so we'll need to say 3 dogs to 6 cats is equal to something. And that's where we talk about our equivalent ratios. Equivalent ratios are exactly like equivalent fractions. So we want to find an equivalent fraction. We simply multiply the top and the bottom by the same number, or we can divide the top and the bottom by the same number. So in this case, for 3/6, we could have an equivalent ratio of 1 to 2. In that case, we divide 3 by 3 and we get 1. We divide 6 by 3 and we get 2. Or we can multiply by 3, or multiply by 2, or multiply by any number, in fact. We can do this times 2, and this times 2, and that will give us 3 times 2 is 6, 6 times 2 is 12. So an equivalent ratio for 3 dogs to 6 cats would be 6 dogs to 12 cats. So we have two equivalent ratios. Let me get this out of the way here. 3 dogs to 6 cats is equivalent to 6 dogs to 12 cats. These two are the same. If I divide those out, 3 divided by 6 is going to give me 1 over 2. If I divide 6 by 12 and I simplify that all the way down, I'm also going to get 1 over 2. So they are equivalent ratios. And that is the definition of a proportion. Now, there are a couple of ways that we can know that two things are equivalent ratios. Let's take that same example there. Let's do 2/4, and we'll say to 4/8. There are a couple of ways we can know that this is a proportion. First of all, we know that 2 times 2 is equal to 4. And we know that 4 times 2 is equal to 8. Therefore, we know, if we multiply these by the same number, that they are going to be equivalent. We multiply the top and the bottom by the same number, it's going to be an equivalent ratio. Now, one nice thing about proportions is that there's another way to do it. Let's take the same ratios, same proportion, and let's do something different. Let's do what we call cross multiplying. Now, when we cross multiply with a proportion, we will get two things equal to each other. In this case, 4 times 4 is going to be equal to 16. So 4 times 4 is equal to 16. Now, conveniently, 2 times 8 is also equal to 16. We know that any time we do cross multiplication and it is a proportion, that we're going to get the same result. Well, let's see what would happen if we did cross multiplying with something that was not a proportion. So here we have 2/3, and we're going to say that it's equal to 4/8. So let's find out if it's a proportion. 2 times 2 is 4. 3 times 2 is not 8. 3 times 2 is 6. So we know that that would not be a correct proportion. Let's see what happens if we use our cross multiplying. 3 times 4 and 2 times 8 is what we're going to do to cross multiply. 3 times 4 is equal to 12. And 2 times 8 is equal to 16. Are these two equal to each other? in this case, they are clearly not equal to each other. So we know that this is not a proportion. This is not a proportion. Now, when we were over on the other side, we saw that we got these two equal to each other. So this is a proportion. This is a proportion. We have two ways to do it, but using the cross multiplication is going to become very helpful in our next step. Okay, now let's take a little bit of time to look at how exactly what we know about proportions can help us in solving and completing proportions that have a missing value. In this case, we have a missing value in our proportion. We don't know what the value is for n. In the last slide, we noticed that we could do cross multiplication to get two things that were equal to each other. Now, once we get two things that are equal to each other, now we're looking at being able to solve an equation. So if we can get two things equal to each other, we can find the value of n by solving an equation. In this case, 3 times n, we know, is going to give us 3n. 2 times 27 is going to give us 54. So 54 is equal to 3n. Now, if you remember, when we did our solving equations, we have three goals anytime we want to solve an equation. Number one, we want to get the variable all by itself. To do that is our step number 2. We're going to use inverse operations. Well, we're multiplying 3 times n, so that means we're going to divide by 3 to get n all by itself. And the reason we can do that, again, is because 3 divided by 3 is equal to 1. And 1n is really just n. So n is what we have left on the left-hand side when we divide by 3. 3n divided by 3 is equal to n. Now, the third rule that we had was that we have to make sure that whatever we do to the left side of the equation, that we also do to the right side of the equation. So we'll make sure that we divide 54 by 3 as well. 54 divided by 3 gives us 1, because 3 goes into 5 one time. That leaves us with 2, 24, 18. Okay, so n is equal to 18. So that means if we want to, we can plug our values back in. We can say 2 over 3 is equal to 18 over 27. Well, let's check and see if that's correct. 2 times 9 gives us 18, and 3 times 9 gives us 27. So n is indeed equal to 18. Now, that was kind of a nice example in that we could check it really quickly, and it gave us some simple answers, but sometimes it's not always that easy. So let's use another example. Let's try 2.6 over 3.4 is equal to, let's say, 1.3 over 1.7. Now, that's not quite as easy to look at. In this case, we're not sure what we're going to multiply by or divide by in this case. So let's take a look at it. We know that because it is a proportion that we can do our cross multiplication. So let's do our cross multiplication. And you can pull out your calculator. 2.6 times 1.7 is equal to 4.42. So we know that that's equal to 4.42. Now, let's do our cross multiplication this way. And 3.4 times 1.3. 3.4 times 1.3 is equal to 4.42. Well, because those two are equal to each other, we know that this is a proportion. 4.42 is equal to 4.42. So if we were to look at this and try to solve an equation for its value, let's go ahead, since we've already done it, I want to go ahead and show you how we can solve this as an equation. So in this case, we would say 3.4x, because we did our cross multiplication. 3.4x is equal to 2.6 times 1.7. So let's pull out our calculator again. 2.6 times 1.7 is equal to 4.42. We just saw that earlier. So 4.42. Now we'll make sure that we do the same thing we did before. We'll solve by dividing on the left-hand side. We want to get x all by itself, so we do inverse operations. 3.4 times x means that we need to divide by 3.4. 3.4 divided by 3.4 leaves us with just plain old x right there. And that's going to leave us equal to 4.42, also divided by 3.4, because whatever we do to the left side, we also have to do to the right side. Pulling up our calculator again, 4.42 divided by 3.4 is equal to 1.3, so 1.3. And we saw earlier 2.6 over 3.4 is in fact equal to 1.3 over 1.7. So anytime we want to solve for a missing value, all we do is we cross multiply, and then we get an equation. Once we have our equation, we simply solve for the missing variable. And that will bring us to our last step. So we just looked at how we can solve proportions that have missing values. Proportions that have missing values. So let's say we had a proportion like this. 1/2 is equal to something over 4, x over 4. We saw that to solve that, all we have to do is to cross multiply. So we multiply 2 times x and we get 2x. Multiply 1 times 4 and we get 4. Then we solve our equation. So we want to get x all by itself. We simply divide 2 using our inverse operation by 2. 2 over 2 is 1, which leaves us with 1x, or just x. Whatever we do on the left-hand side of the equation, we have to do to the right. So 4 divided by 2 is going to be 2. And x is equal to 2. So 1/2 is equal to 2/4. We saw how to do that just before. Let's take that same idea and let's use it to solve some real-world problems. In this case, our question says, if we have 3 apples that cost $6, how much would 12 apples cost? Assuming that the same price applies. 3 apples cost 6. How much would 12 apples cost? So we're going to set up a proportion to solve this problem. The thing about proportions is that there must be a relationship between the numbers that we want to set up the proportion for. We know that there is a relationship between apples and cost. Every 3 apples, we're going to pay $6. That's a kind of a rate there. For every 3 apples, we will pay $6. So 3 apples per $6. We want to know how much 12 apples would cost. We want to know how much 12 apples would cost if 3 apples cost $6. Now, it's important when we're solving things with proportions that we keep the units matching across the proportion. So in other words, if we have 3 apples to $6 and the apples are on top and the dollars are on the bottom, then however we set up our proportion, the apples have to be on the top on this proportion as well, and the dollars have to be on the bottom as well. So in this case, we're going to put our 12 apples right here on top, because apples to apples, if you will. And then $6, and we don't know how much 12 apples cost, so we'll use x for our amount of dollars. Then we'll do exactly what we did before. We'll simply do our cross multiplication. We'll multiply 3 times x and 6 times 12. 3 times x is, of course, 3x. And 12 times 6, let's pull up our trusty dusty calculator. 12 times 6 is 72. So we'll say 72. Now we simply need to solve our equation. So we want to get x all by itself. To do that, we need to use inverse operations. We're multiplying 3 times 6 in this case, so we want to use the inverse. The inverse of multiplication is division. So we'll divide 3 by 3. Now, 3 divided by 3 is 1, so that leaves us with 1x, or simply x. And then we know that if we're going to solve an equation, whatever we do on the left side to keep it balanced, we have to do on the right side. So we'll do 72 divided by 3. What is 72 divided by 3? We could do it in our head, but we'll go ahead and calculate it. 72 divided by 3 is 24. 72 divided by 3 is 24. So my answer is if 3 apples costs $6, then 12 apples would cost 24. And we'll take a quick look at this since it's a convenient number. 3 times 4 is equal to 12, and 6 times 4 is equal to 24. So we know that we have the right solution. Let's take a look at another problem then. We have one here where it says the ratio of 7th graders to 8th graders participating in the science fair is 4/3. 4/3. And there are 18 8th graders participating in the science fair. Then how many 7th graders are there? No, we know that we have a ratio already in place for us, the ratio of 7th graders to 8th graders. So if we were to write it out, we would say 7th graders and 8th graders. And the ratio is 4:3. So 4 7th graders to 3 8th graders. Now, we also know that there are 18 8th graders. We know that there's a relationship between 7th graders and 8th graders, that the ratio is 4:3. So, if we have 18 8th graders, we have to make sure that we put those on the bottom with our other 8th graders. Then how many 7th graders are there? Again, we know that there is a definite relationship between 7th graders and 8th graders. 4:3 is equal to how many to 18? So let's write that out. 4/3 is equal to something over 18. That allows us to do our cross multiplication. So we'll multiply 3 times x and 4 times 18. 3 times x is simply 3x. 18 times 4, let's crank out our calculator here. 18 times 4, 4 times 18 is equal to 72. Then we simply solve our equation again. 3 times x, we'll use inverse operations, which means we'll divide by 3. 3x divided by 3 leaves us x. And to keep it balanced, we divide by 3 on this side, which leaves us with 72 divided by 3. 72 divided by 3 is 24. So x is equal to 24. How many 7th graders are there? There should be 24. Let's take a look at it and check it. 4/3 is equal to 24 over 18. We know that 4 times 6 gives us 24, and 3 times 6 gives us 18. So in fact, this is the proper relationship, and so for every 18 8th graders, there will be 24 7th graders. Then one last problem, just to run one more by you. At discount copy, we find out that 12 copies cost 66 cents. Melissa, however, needs 56 copies. So how much should they cost? We're given a ratio or a relationship. We know that 12 copies costs 66 cents. And we're going to set a ratio equal to that, which will mean that we have a proportion. So 2 equivalent ratios gives us a proportion. We need to make sure that our copies match up. We couldn't put copies down here on the bottom. We have to make sure that copies go on the top of our ratio here. So 56 copies is equal to how many cents? So we'll do our cross multiplication one more time. 12 times x and 56 times 0.66. That leaves us with 12x equal to 56 times 0.66. We really need a calculator this time. 56 times 0.66 is equal to 36.96. 36.96. So $36.96. That tells us how much all of them would cost. 12 times the number of cents is. So 12x, we want to find out what 36.96 divided by 12 is. And that gives us a total of $3.08. So x is equal to $3.08 because we solved our equation, simply divided here, and we divided this by 12, and that gives us $3.08.